In our past lecture, we looked at the minimum force P1 that will keep the body in equilibrium when it is at the point of sliding downwards. In this lecture, we look at maximum force P2 that will keep the body in equilibrium when it is at a point of sliding upwards. We are dealing with motion of a body on an inclined plane when it is subjected to a horizontal force P. So let this force be P2 and this be reaction R2, the normal reaction as a result of this inclined plane on the body. And it has a weight W, okay? And the angle with which the plane makes with the horizontal is alpha. So geometry will obviously tell you that these are alternating angles, and therefore this angle will also be alpha. So now, a little more consideration when we consider the equilibrium of this body on an inclined plane will show you that this is W cos alpha, and the angle, of course, I mean the component, the other component of this weight W is going to be W sine alpha. So when the body is at a point of sliding upwards, that means the force of friction will act downwards along the plane because the body is at a point of moving upwards, and frictional force will always act in opposite to the direction of the body. So this is friction F2, friction force F2. So that friction force F2 will therefore equal to nu R2, whereby nu is the coefficient of friction between the body and the inclined plane, and R2 is the normal reaction on the body. So in this case, the force of friction is F2 equal to nu R2, as we have said, and will act downwards as the body is at a point of sliding upwards. So resolving forces along the plane. So if we resolve forces along the plane, we will have P2. Okay, I'll resolve it. So along the plane, it will go through an angle alpha, so it becomes P cos alpha, which will equal to which other forces? We will have F2 plus W sine alpha. So we'll have P2 W sine alpha equal to, so this is coming from P2 cos alpha equal to W sine alpha plus F2, whereby F2 is nu R2. So that is our equation. You can call it equation number 1. Okay. Then we also need to obtain another equation, and we do this by resolving forces perpendicular to the plane. So here always it is known that we resolve forces along the plane and forces perpendicular to the plane. So we are saying along the plane always, and then two, we resolve perpendicular to the plane. So when we resolve perpendicular to the plane, the forces that are at 90 degrees to the plane include R2, a component of weight, which is W cos alpha, and also a component of P2, which is P2 sine alpha. So for that matter, therefore, we'll have our R2, which will equal to, because W cos alpha is facing downwards, and P2 sine alpha is also facing downwards. So those are two equations that we need to solve, and then get the value of P2 and then move. So from here, we can see that R2 can be substituted. So substitute for R2 in equation 1. So what does that give us? So I'll have P2 cos alpha equal to W sine alpha, okay, W sine alpha plus nu R2, whereby R2 is W cos alpha plus P2 sine alpha. So I can correct the right terms so that I have P2 cos alpha minus nu P2 sine alpha equal to W sine alpha, okay, W because it is common, so I can put it outside, so it becomes nu cos alpha, okay. So this is P2 into cos alpha minus nu sine alpha, which is going to be W into sine alpha plus nu cos alpha. What do we do with this? So what we can proceed with is introducing the fact that nu is equal to tan phi and is equal to sine phi divided by cos phi. So if I introduce it in here, I'll have P2 into cos alpha minus sine phi divided by cos phi times sine alpha. This is equal to W sine alpha plus sine phi divided by cos phi times cos alpha. So what if I multiply by multiplying cos phi both sides? I will not have changed anything, but I'm trying to manipulate something here. So P2 into cos alpha cos phi minus sine phi divided by cos phi sine alpha times cos phi, okay, will equal to W sine alpha cos phi plus sine phi out of cos phi cos alpha cos phi. So what do? I cancel this and that, and what shall we remain with? Obviously, we will remain with P2 into cos alpha cos phi minus sine phi sine alpha equal to W into sine alpha cos phi plus cos alpha sine phi. Now we already know that sine alpha cos phi plus sine phi cos alpha is equal to sine into alpha plus phi. And we already know that cos alpha minus phi is the same as cos alpha cos phi minus sine alpha sine phi. So if I use these compound angles and introduce them in this equation, I'll have P2. Our P2 therefore will equal to W sine into alpha plus phi divided by cos alpha plus phi, and this will obviously give you W tan phi plus alpha. So the maximum force that will keep the body in equilibrium when acting horizontally and at the point of sliding upwards, that P2, the maximum force, will equal to W tan of alpha plus phi. So given a problem that you have an angle alpha, you have the angle of friction phi, the W, which is the weight of the body, you can be able to calculate that maximum force P2 that is required to keep the body in equilibrium when it is just at the point of sliding upwards.